In question 5, we're told Thomas Young showed the interference of light by illuminating two closely spaced narrow slits with light from a single light source. In part A, we need to state what this suggested to Young about the nature of light. Well, interference showed Young that light was behaving as a wave, not a particle. In part B, we're told the demonstration can be carried out more conveniently using a laser, which produces coherent, monochromatic light. In part 1, we need to state what is meant by monochromatic. Monochromatic means light of one wavelength, and therefore one colour. In part 2, we need to state what is meant by coherent. Well, coherent means the sources have a constant phase difference, which can be 0. In part 3, we need to state a safety precaution that should be taken while using a laser. Well, it is important to ensure nobody looks into the laser. In C, we have a diagram of the maxima produced from a two-slit interference experiment using a laser. We're told the slit spacing is 0.30 mm and the distance from the slits to the screen is 10 meters. There are 9 maxima shown with a complete separation of 0.16 meters. We need to use this information to find the wavelength of the light producing the pattern. Well, first we can find the fringe separation, which is 0.16 meters over 8 gaps between the 9 maxima. This is a separation of 0.02 meters. Then we can use the maxima separation is equal to lambda d over s, where lambda is the wavelength we want to find, d the distance to the screen, and s the slit separation. Rearranging for lambda, putting in the values given, gives a wavelength of 6.0 times 10 to the minus 7 meters. In D, we need to state and explain the effect on the pattern of using light with a shorter wavelength. Well, light with a shorter wavelength will produce closer maxima. This is because the separation between the maxima W is given by lambda d over s, and as the slit separation s and the distance to the screen d is kept the same, the fringe separation W is then directly proportional to the wavelength lambda.